What does it really take to predict the unpredictable? To see turbulence before it happens? To trace a jet stream across continents? Or to forecast a volcanic ash plume before it disrupts global travel? Welcome to the next level of meteorology, where cutting-edge tools and advanced forecasting techniques come together to help us master the skies. The evolution of forecasting. Meteorology has come a long way from weather vanes and handwritten observations. Today, aviation meteorology blends atmospheric science with powerful technology to anticipate weather with astonishing precision. For professionals guiding aircraft through unpredictable skies, these tools aren't just useful, they're essential. As commercial air traffic becomes increasingly complex and climate variability grows, so too does the need for accuracy. Forecasting isn't just about looking ahead anymore, it's about staying ahead. Numerical weather prediction models. At the heart of modern forecasting lie numerical weather prediction models, or NWPs. These are massive computer simulations that analyze atmospheric conditions using mathematical equations based on physics and fluid dynamics. Models like the ECMWF, GFS, and UKMO provide global and regional forecasts by ingesting real-time data from satellites, weather balloons, aircraft, and surface stations. These simulations can forecast weather patterns several days into the future, offering aviation meteorologists a foundation to predict turbulence, cloud layers, and frontal systems with great detail. Forecasters often compare multiple models, a practice called ensemble forecasting, to identify trends and reduce uncertainty. It's a bit like watching the same weather story unfold from different perspectives. High-resolution radar systems. While global models give the big picture, radar provides real-time local detail. High-resolution Doppler radar systems track precipitation, wind speed, and storm structure at a granular level. This allows meteorologists to detect the onset of thunderstorms, hail, and even the rotation within storm cells that may lead to tornadoes. For aviation, radar is indispensable. It helps predict microbursts, sudden downdrafts that can be catastrophic during takeoff or landing, and tracks squall lines that may cause severe turbulence. Some advanced radars are now dual-polar, allowing forecasters to distinguish between rain, snow, and ice crystals, critical distinctions for aircraft safety. Satellite imaging and remote sensing. When it comes to watching the weather from space, satellite technology offers a bird's-eye view. Instruments like the GOES and Meteosat satellites provide high-frequency images of cloud cover, storm development, and jet stream movement. Infrared imagery helps identify cloud tops and temperature gradients, while water vapor channels track atmospheric moisture, a vital factor in storm development and flake planning. These tools are especially valuable for remote oceanic and polar regions, where radar coverage is limited. Nowcasting, the art of the immediate. For short-term precision, forecasters turn to nowcasting, a technique focused on predicting weather for the next few hours. Using live radar, satellite data, and surface observations, nowcasting is essential for high-traffic airports and during fast-moving storm systems. It's in the nowcasting window that meteorologists issue critical updates, such as SIGMETs and AIRMETs, which alert pilots and air traffic controllers to significant weather phenomena. These updates can help avoid delays, diversions, or dangerous in-flight conditions. Machine learning and forecasting innovation. Meteorology is now entering the age of artificial intelligence. Machine learning algorithms are being trained on decades of historical data to improve the speed and accuracy of short-term forecasts. These systems can rapidly analyze patterns that humans might miss, providing insights into storm intensity, turbulence zones, and wind shear. Some advanced flight planning systems already incorporate AI-based forecasts to suggest optimal altitudes and routes in real time. While these technologies are still evolving, they are quickly becoming indispensable to aviation meteorologists and dispatch teams. Integrating tools for maximum impact. The most effective meteorologists aren't just experts in each tool, they know how to combine them. For example, The forecast for a transatlantic flight may start with a global NWP model, be refined with satellite imagery, and then be updated with radar and nowcasting as the aircraft nears its destination. It's this integration, combining the large scale with the immediate, the predictive with the observed, that defines mastery of the skies. Mastering the skies isn't about eliminating uncertainty, it's about reducing it to a manageable level. With every model run, satellite scan, and radar sweep, aviation meteorologists are pushing the boundaries of what's possible in forecasting. For those who love technology, thrive under pressure, and are captivated by the atmosphere's complexity, this fusion of science and strategy is the ultimate career challenge.